Okay, so we will be checking to see whether the Pythagoras relationship of the three sides holds together, which is the two short sides, those two. If I square that and I square that and add them together, it equals that squared. Let's find out. So we've got our three sides, A, B, and C. Now it doesn't matter which one I call A and B, but C has to be the longest one. And the longest one is the one that's not connected to the right angle. You can see there it's the one across from the right angle. Okay. The other two, the shorter ones, are both touching the right angle. In fact, they're forming the right angle. Okay, so let's have a look here at the value. Which one am I going to call A? Let's pick this one can be A or this one can be A, doesn't matter. But I'll call this one A because I started there, and so A is 6. B is the other one, which is 11.53. And you'll have to excuse the odd numbers here, but that's just the way it is. And C is 13. All right, now we're going to test whether A squared plus B squared equals C squared. So first of all, what I need to do is I need to square this number. And so when I square something, A squared means A times A. It means two of them times together. And so this is going to be 6 squared, which is 6 times 6, which is 36. So there's my A squared there. Now B squared is 11.53 squared, which is 11.53 times 11.53, and I don't think your times tables are going to help you out too much there, apart from knowing that it's going to be somewhere between 121 and 144, which is 11 and 12 squared respectively. So we're going to get out the old calculator here, 11.53 times 11.53, and what do we get? We get 132.9. 0.9409. It goes on for a bit. I'm just going to keep it at 132.9. And now we've got C here. C is 13, and so I'm going to square 13, which is 169. Okay, now what we're going to do is we're going to test whether A squared plus B squared equals C squared. Does that work? Well, let's have a look at the numbers. So we'll use 36 plus 132.9. Does that equal 169? Well, if I add these two together, I get 168.9. Is that the same as 169? Well, it's extremely close. And we have to remember here that this number was rounded off a bit. There were more places in the calculator, which means that the number is actually a tiny bit bigger than this. And if we make our answer a tiny bit bigger, we're going to get to this here. So it's looking good. It's not perfect with this because we've done some rounding here, but it's very close. Let's have a look at another example. So I've got number 10 off the sheet here. We'll do the same thing with this one. And I'll just move that out of the way over there. Okay, so same deal here. What we're doing is we're checking to see whether the two short sides, if I times them together, equals the long side times together. So once again, we do A, B, and C is the only one that we really need to make sure that we get in the right place. Here's the square corner. I just added that in. You should do the same. And this is going to be C because it's the one that's across from the right angle. Now the other two sides we'll call A and B. Let's call this one A this time, the one down the bottom and the one B over here. You'll get exactly the same answer if you swap those over, just the numbers will be in different places here. Okay, so let's have a look at what we've got. A is 16, B is 9, and C is 18.358. All right. Okay. So we've got our A values, A value, B value, C value, and what we're testing for here, as before, is to see whether the squaring of that added to the squaring of that equals the squaring of that. So let's find out. Now a squared is 16 squared, and 16 squared from memory is 256, but I'll just check that. Yep, 256. Don't want to get the numbers wrong here. So that's 256, that's fine. And then b is 9, and 9 squared is 81. There we go. And c squared, which is 18.358. If I square that, 18.358. Have not got a hope of being able to do that without the calculator. I get 337 point, and then there's some decimal places, 0.16164. So if I was going to round that off, I'd go to 0.02 because I would be rounding the 0.016. Would go to 0.02 because remember, if I'm rounding to here, I look at the next one, is it 5 or more, then I increase it, which is what I've done there. So I've just rounded it off to keep that decimal there. Now let's check by adding these two together. I get 337 on this side here, 337.02. And so clearly, we're getting very, very close here. Whenever we've got a rounded, this number here has actually had a bit of rounding done to it as well. It must have done. But we can see that it's working. The numbers here are virtually identical, and with a little bit of rounding off of this number here, that explains that tiny little difference there. Now that's not a proof of why this works. It's simply showing that we can put the numbers from any right-angled triangle into this a squared plus b squared equals c squared formula, and it will work. The two sides will balance.